So, here we go with the ball launching problem. From the top of a 120-foot building, a ball is thrown at an angle of 20 degrees with an initial velocity of 75 feet per second. Okay? Before we figure out how high the ball is after 1.5 seconds, or before we figure out when the ball hits the ground, or any of the other questions that we may have, we should probably figure out what the equations are of the situation. So, what is the x equation to model this situation? 75 times the cosine of 20 degrees times t. Anything else? Nope. Okay. What's the y equation? Negative 16 t squared plus 75 times the sine of 20 degrees times t plus 120. Okay? So those are our equations. Yes? I would agree with those. Let me see if I can move this one over to there, which makes this be able to come up. So my question to you is, what is the height of the ball after 15 seconds? How do I find that? In which one? In the y equation. Yes, I would just put the height of the ball here then is negative 16 times 1.5 squared plus 75 times the sine of 20 degrees times 1.5 plus 120. So when I do that, negative, so if I go 1.5 and I store that as my t, okay, then I can go negative 16 t squared plus 75, oops, I should put that in a set of parentheses. Oops. 75 times the sine of 20 degrees. Now, I will tell you this, that it is extremely important for you to determine what mode your calculator is in. You need to figure out if your calculator is in radians or if it's in degrees, because in this problem we're using degrees. In the Ferris wheel problem, which a lot of people are having issues with, they're running that in degrees. That needs to be in radians. Ferris wheel's in radians. These launch angles are in degrees. Okay, so this needs to be in degrees. Times t plus 120. So that tells me that my ball is 122.477 feet above the ground. Okay? When does the ball hit the ground is the next question. Okay? When does the ball hit the ground? Well, to solve that one, I have to figure out my y equation, negative 16t squared, plus 75 times the sine of 20 degrees times t plus 120. I need to figure out when that is 0. Okay? So how I would go about doing this one is I would store negative 16 as my A value. I would store 75 times the sine of 20 degrees as my B value. And I would store 120 as my C value. I would store all of those in my calculator. Now, by doing that, what I have allowed myself to do is now I can just type in the quadratic formula. The opposite of B plus the square root of B squared minus 4 times A times C all over 2 times A. That's going to give me one of my zeros. Is that a zero that I want? No. Okay? But I might need it later on, right? So I'm going to quick store that as I'm just going to use N for not my zero. Okay? Right? So that gives me the first one, so negative 2.05191. Then I can go back into, and I can just go, whoa, tap the brakes. Why won't it let me just go back up here? There it goes. I can just go back right there, and all I've got to change is that plus sign to a minus sign. And that's going to give me my other zero of 3.65513. Hold on, now we're over here. There we go. And that's the one that's going to tell me when it hits the ground. Okay? So that one I'm going to store as my, we'll put that one in as T. Okay? Bless you. All right. So, there we go with that. Okay? So then it's asking for me, so that's when does the ball hit the ground. Then it's asking what is the maximum height of the ball. Well, the maximum height of the ball, where am I going to find the maximum height of the ball? Could I just, what?
I'm going to say divide T by 2.
I cannot divide T by 2. I would be able to divide T by 2 if the first zero was at 0. Then I could divide T by 2. But the first zero is not.
You find the T0, like where your x values are at 0, and then divide that by 2. Or like do the difference between them to get the middle.
So what, but didn't I already find them? Or do I need to find the x values? Or do I use time now? Help them out. Do I use time or do I have to put those x values, put those t's back in for the x equation? I'm just using time, right? So I just have to average those 2 times. So the time value that we get when the ball is at its maximum height is going to be the average of, in my case, T and N. And I'm going to divide that by 2. And that's going to give me, so at 0.80161 seconds, that is going to be, we'll call that V for apparently I can't do V. I can do V that way. We'll put it in as V. Okay? So that is going to be at t value of 0.8, forgotten already, 0161. Okay? So what do I put that into? This one up here was n. N was my other 0. Yep. Okay. All right. So I put that into my y equation, right? So negative 16. Now in this case, I stored it as v squared plus 75 sine of 20 degrees times v plus 120. Now, here's the cool thing about storing all that stuff. Okay? So you've got negative 16, and we said v squared, plus b, we got that stored as b times v, plus 120. We already got all that stuff stored on there. So it gives me a maximum height of 130.281 feet. How far away from the building does the ball hit the ground? Well, I know that it hits the ground at a t value of, what did we say, 3.655 seconds. So where is that? What do I put that one into now? My x equation. So x here is going to equal 75 times the cosine of 20 degrees times 3.65513. 75. Unfortunately, oh, tap the brakes. Where did you go? Unfortunately, 75 times the cosine of 20 degrees times, the only thing I've got stored in here is my t value, and that gives me 257.602 feet out.